Good morning. Great that some of you made it on the first slot. My name is Tim, and I'm going to present you the project Close-Lit to Encrypt. Thank you for giving me the opportunity to speak here in front of you. So, what is Close-Lit to Encrypt? It's a project by Jonas Meurer and me. We are both freelancing system engineers living in Germany, and we're planning to bring full disk encryption into the suspend mode for Debian and hopefully its derivatives. So, why is it useful to you? Full disk encryption only protects the data while it is at rest, which means when your system is powered off, which for most people is like very little time anymore because they just like close their laptop and take it somewhere. So we're trying to improve this time span where your system is protected to all the times when it's in suspend mode or sleep mode, which is the same. And hopefully this will save your data at night or while you're on the move or while your laptop is on a train or something. So first of all, why is this even difficult? Well, we're locking away your running operating system. If this doesn't sound difficult to you, lucky you, it was difficult to me. So there's all kinds of race conditions then that can happen. Since we've locked away all of your file systems, the kernel might want to access it because some process is requesting something that would be like that would a file on your system. So we have to make sure that we really know what happens before we enter the suspend mode and after we resume, and that only processes access some data once we have unlocked the system again. Well, and then there's the thing that usually memory management is transparent, which is great. You don't have to care if you're developing an application. But since the swap space is located on your hard drive, which we will encrypt and lock, and the memory is actually unencrypted, we have to be sure what part of the memory is located where. So since this is the dev room, I'm going to dive in right into the details of how we implemented this. So systemd is standard in Debian nowadays, so we start with a drop-in unit for systemd, and we override the command that happens on suspend mode. Usually it calls a binary called sleep.c, and we override it with a wrapper for our purpose, which we call crypt setup suspend wrapper. This wrapper then uses the init rumfs that you have already used during boot. I mean, I'm guessing you have a full disk encryption here, right? So otherwise, all this doesn't make sense. So we're reusing this and loading it into a rumfs in your memory. Then we're using the unified C groups hierarchy to transparently freeze all of your processes. So every C group has something that is like a freezer attribute, and we just call it to freeze. Something systemd tells you shouldn't do because it's like interfering into all kinds of processes, but it seems to work quite well at the moment. Then we change root into the rumfs, and we call our own binary encrypted up suspend. So what this does is it first locks a lot of memory, because we need a lot of memory afterwards, because standard key derivation hash function is argon2i, which is memory hard, which means it needs a lot of memory. So we have to make sure the memory is actually available. Then we're telling the kernel to not sync before suspend. There's an attribute called sync on suspend. Then we manually sync the system, meaning writing everything from memory to hard disk that is should be written there. Then we do the lux suspend of all your lux devices. and then we suspend this. We tell the kernel to suspend, which it then does in the way that it usually does. So what is this attribute, syspower sync and suspend? Yeah, it's our first accepted kernel contribution. We were very happy. It was a long way. It's a tiny patch, but it's coming in actually the next release in 5.6. It was a very interesting exercise in interacting with the open source community. And yeah, I can tell you later if you're interested. Basically, it is a runtime flag that tells the kernel if it should sync before suspend or shouldn't. There has been a build time flag before, which we obviously couldn't use because we're aiming for upstream adoption. And not everyone wants to use our program, probably. So going back into the details, the kernel has suspended, and now we wake it up afterwards. It resumes. It gives back the power to the process that was running before suspend. In this binary, we unlock all the devices that we have locked before. We go back out to the wrapper, and basically we just reverse everything that we did before. We even unlock your GDM session or something. Okay, so since I have very little time, I had to pre-record the demo. So I hope that you believe me that it does what I will tell you. But otherwise, I have running this, it's running on my system right now, so you can also check later. So here I am, minding my business. I'm suspending the system there. Yep, it's suspend now. I'm sending a CPI command to wake it up again. And I hope you can see it asks for the password of your encrypted device. It could be multiple devices. You could use all the functions that have been there in the encrypted package before. So you can use key files, like special security keys or whatever. All right, what's next? So we need to do more testing, right? The suspend mode is something that is very particular, so we have to test it on all kinds of different systems, and we hope that maybe some of you will help us with that, because we're very soon going to merge the code with the upstream encrypt setup package, so that in Debian testing you can then just install encrypt setup minus suspend, and it will transparently encrypt your file system when going to suspend mode. We're waiting basically for the new kernel to come upstream as well, to be released, so that it makes sense that you can actually do some testing without compiling your own kernel. Then there's this very tricky situation if you are low on memory. As I said, Argon 2i, it needs about usually 1 gig of RAM when unlocking the device, which you might not have. So if you're very knowledgeable about kernel memory management, please talk to me. Obviously, there are more secrets in your memory than just the LUX keys. So we were planning to include some scripts to get away some of those secrets as well. Yep, and then I want, I'm short on time, sorry. I want, of course, to thank the original encrypt setup authors. I want to thank the encrypt setup maintainers who had the idea for this project, Guillem and Jonas, whom I've been working with, which was really great. And there have been people trying to tackle this problem before. I think our approach is the most advanced one, but they have done great work as well. And last but not least, I want to thank Prototype Fund, who has been funding this project in the last 5 months. They have a new round open. You can apply if you live in Germany. They fund open source work. And yeah, if you're interested, you can visit our GitLab repo, open some issues, or send the email personally. Thank you very much.